Pizza Ranger, what do you mean tell make it? I say hi. I'm here. And also Cookie wishes were Wednesday already. Oh, me too. This is one of these technical... Well, honestly, I spent the last, I think, 3 days just preparing for the 400th child checkup. And I'm done actually. I'm prepared. I have everything ready, but it's not 400 yet. So yeah, I've paid for it tomorrow. Well then, good luck I suppose to other side. Speech one just here. Just left, right before. Hi the people, by the way. Oh boy. Yeah, it's not 400 yet. I genuinely spent the last 3 days just preparing stuff. When it's gonna be, I have no idea. That's actually pretty awkward. I kind of screwed myself over a bit because yesterday I was really tired. You know, after the all night, I apparently I only slept for 6 hours, and I thought, yeah, it's fine. Apparently, it wasn't fine, and so I kind of screwed myself over by going to sleep, and now I'm well rested, but I shouldn't be well rested because I should actually go to sleep early today to set up the night tomorrow. But yeah. Tomorrow, hopefully. Yeah, hopefully, am I right? Yeah, it's actually gonna be fun. Today, I don't actually honestly know exactly what we're gonna do today. I was thinking maybe we should... What are we up to today? Well, Feeble, you got timing. Let me tell you that much. I was thinking, actually... Hold on, my Windows glitching. I was thinking... Well, here's the thing. I'm tiniest little bit behind the video. Not much, but a bit behind. Videos, actually, plural. Second of all, there's a couple of physics things which I would really like to research. So, I know what we should start with, actually. Anyone y'all wanna have a vote? Let's have a vote. Start the Q&A. No, that's wrong. Poll. We'll do what we doing. Waves in 3D. Well in 3D. Or dynamics from scratch, or drone research, drone motor research. Pick away. My chat just broke because of this poll. Have Alex comes. I don't think. Well, yeah. I mean, I would like Alex come as always. But we actually don't have quantum mechanics. Well in 3D? Yeah, as in well, you know. Well, as the thing we have water. Well. like well. Well, 3D, I mean, you know. Seems pretty reasonable. Is the music too loud, by the way, or am I too quiet, or both? There we go, it's a bit better. Aerodynamics from scratch! Wow, if only I could have seen that coming. I was hoping that from scratch would lower your enthusiasm a bit. That's it's from scratch. I've never done aerodynamics, so it's not gonna be quick. 50. I will give you a second though, because there are only 4 votes. There are only 4 people. Oh, every single person voted. Democracy, powerful stuff. But just for the aerodynamics, that would be physics. I found one book which was really solid. I like aerodynamics in it. Aerodynamics is just about the friction in liquid, basically. That's how I understand it. Well, air is a liquid, close enough. 40%. Yeah, most people. Oh, and on drone motor research, that's nice. It is a tie. Oh no, it's not anymore. It was a tie. I'm looking for thermodynamics, modern physics. Oh, this. Oof, no. Physical science. Classical mechanics. That seems reasonable. Oh! I pulled up my vote. I put up my alt to vote for drone and it's still lost. Oh, you and the drone are... Wait. When you have 2 votes, the only ones, actually. Well, fine, we'll also do some drone. Okay, no one cares about the well, and that's perfectly reasonable. You know what? That's what we should do. We'll start a bit with aerodynamics, then we'll do some drone motor research, and then we'll do waves in 3D. Okay. So first we need to find the source, right? Transistors and actually in detail, and that's all I can think about. Waves do seem some fun. Oh, waves are climbing up. Oh, it's a fight. Waves are gonna slowly moving forward. Aerodynamics from scratch still holding strong at 44%. Drone motor research in the back with 22, and well in 3D with 0. No one voted for it. Waves still stairs holding still 9 votes. 9 votes. Can you get some more? Can you get some more, please? Anyone voting? Anyone? Is that the final result? 3 minutes, 9 votes. Aerodynamics from scratch 44%. Waves 33. Drone motor research 22. There be any last minute changes? Last minute? Okay, apparently not. Alright. I mean, let's be real. Aerodynamics sounds the coolest on paper. And I have no idea if it is or if it isn't. As I mentioned, I've never done aerodynamics. Hold on. If we go just to physics, bookshelves, if I'm not mistaken. We have college, university, classical mechanics. I think it's classical mechanics, right? I hope so. Modern physics, ooh, don't want that. Oh, I don't want modern physics. Waves. Well, gonna bring pen and paper. I have no idea how to do aerodynamics. Oh, I do like Fowler. Fowler was my initial quantum mechanics. Yeah, great. I found a while back. I found a book which had 4 chapters. Waves 1. Oh my goodness! Did you bring your alt accounts into the vote? You're unbelievable. So I'm playing all my drums. I want to know how its models worked. I honestly same. Waves in 3D. Waves got up. Oh my. Okay. How many old accounts did y'all bring out for this? Unbelievable. Unbelievable. Waves in 3D. Okay, it won't be as interesting as maybe. Oh, maybe it will be interesting. I don't know, depending on what you find interesting, I suppose. But here's what I basically want to do. Let me just start the thing first, which will be edit, generate. Oh, they switched up the. Where's subdivide? Subdivision service, precisely what I'm looking for. This is so American voting right now. Okay, let's crank it up to 7. Why not? Don't save. All right, shading. Let's go to a shading stub, and here's how the basic idea will work. How do waves work? That's a great question, and no one actually asked. I'm so glad. Tomorrow's going to be cool. Tomorrow is going to be cool, and I just can't wait. I mean, I'm hoping it will work out. If it won't, then I'll be just a big sad. All right. 8 watching and 13 votes actually. That's because people run their old accounts. Alright, you ready for waves? Here's the thing. What we want to do, right, is we want to create like a pattern of waves. going from the middle out. And now obviously y'all might have a reasonable question, but make it. How would that work, right? How are we gonna create them waves? And that's a great question. Let's think about this. What function could be really useful for describing waves? It's a shame the stream has to exist and we can't just give it to day 400. I know. I feel the same way, trust me. Anyone that's any functions? Yeah, you are absolutely right. Voice in my head. It is sine or cosine, whatever. We'll use cosine because for some reason I won't use cosine. You can describe wave with cosine. Great answer, Nana. That's precisely right. But here's the thing. How would we turn a cosine function into wave propagating from the middle? Well, let's take a look at our gosh dang the best cosine function. I have the answer already. I don't know why I'm building up to it. I could just make it and then we're done. There we go. So we want to basically be able to. Maybe I should just do it in Blender and then explain, because then we'll have a visual. That's probably a smart idea. Basic idea looks like this. If we have a plane, right? We just cut it in half. Then right here we want a cosine function. Okay, that's what we want. We want a cosine function. And so basically this is a. We can count this as a. Then this function will be just cosine of a. And then what's really nice about this is that we can slice it at any angle. Like for example right here. Create a different wave. And this once again, if this new line will also be a, then we have new cosine of a. You can see in 3 dimensions, you can see kind of how it works, see? Yeah, so what we can do is we can take texture coordinate, and I would like emission actually, if we plug it right here. It looks confusing, but the basic idea is simple. Separate XYZ, combine XYZ. We have X, we have Y. I mean, as simple as it could be. And actually, maybe object will be better? Yeah, object will be much better. The reason why object will be better is because 0 in the middle. Which means what we can do now is we can keep the color as white. And we can, vector, math, and distance. Distance, which is basically hypotenuse, but shortened a bit. I'm gonna move this because it's a bit easier, and then value into the strength. And wow, we get a black dot in the middle, which is the exact opposite. Actually, is it? No, it's good enough. So then what we can do is we can just take math, we can take cosine, we can plug it in, and then it's not that visible. That's why we're gonna multiply it too. We have waves! Wow! How is he doing this? This is incredible! Make it! You're a wizard! I know. I'm incredible. I know. But now what we can also do is we can take displacement. This one's actually will take a bit more preparation. This one is more Blender oriented. Displacement and bump. Displacement, and then height. Oh yeah, this is great. And then divide. Look at this. Ain't that awesome? We have actual waves. And what's even better is that if we take this multiply, if we do addition, we can move them in or out. Unfortunately, it's... Wait, maybe I am doing this wrong. I'm doing this with a material, which means I do need the rendered view. If it's not the rendered view, it's not gonna work. A 0 for this one in the middle. That's so silly. So silly. And yeah, and then we can also color it in so that the higher it goes, the brighter it is. And then, whoa, it's actually moving in. And what's really cool about this actually is that if I could just, well, not really cool, relatively cool. You see, this is what you voted for. That's why democracy never works. Oh, aerodynamics from scratch is up 41%. We'll switch rules soon before we finish this. So, the main thing which I want to do with waves is that right now we have only one wave, which is fine and all, except it's boring, right? It's very boring. So what happens if we'll have another wave starting, for example, right here? What will the end result look like? I'm so glad you asked. You see, right here, we have this. Now what we can do is we can just add the results from two waves, right here, and then as an input, use the object, but move it around a bit. I'm pretty certain it's gonna work. Okay, maybe we won't. Hold on. Hold on, pump the brake. Let's pump the brakes a bit. Or maybe it is working and just... It is! Okay, sick. Now we can move this around with these two. So now we want to add them both together, plug in the result, and this is what happens when we have two different waves. This is the pattern we get, and if we increase the add, well, I'd rather increase it for both actually. If we increase the add right here, then we can see how it evolves over time. This is what these waves look like propagating. And this is actually a fairly realistic model of waves. Let's do 0.1 and 0.1. Yeah, and then we can also, for the color, change it up a bit actually. Well, that's a bit too bright. Never mind. And then we can also combine XYZ for the color and use this as X, this as Y. Okay, multiply a bit higher, buddy. It's a bit too dark. There we go. And now we can see that the red is okay. Is this leading double slit experiments? Well, no, aren't you a clever person? Aren't you just clever? Yes, it is. It very much is, because you see, when you have a double slit experiment, let's clean this up. Oh, that's such a mess, actually. Let's clean it up a bit. So, right here, we have our first... Right here, we have our first wave, right? We can increase the value, and there. Why is it a bit... Why is it screwed up like this? I don't know. The point is... Oh wait, it is screwed up. It is wrong. I was supposed to move the distance. I'm an idiot. I was supposed to move these. And these? Hold on. What? Am I crazy or dumb? Or both? Could be both. 0.1. Okay, I plugged all of them in. The same one. So let's keep this at 0, keep this at 0. This isn't moving X because it always stays the same, which means we want to multiply this by -1. Haha! No. Do you have a 3D printer? No, but I know people who do. What am I doing wrong? Okay, let's think about this mathematically. We want... So here's what we have. We have y and x. X and y. And, well, y right here. And then right here we have the 0, 0 point. Now, what we want is we want to create a new kind of wave in which this will be a new 0, 0 point. Which means the distance from... So basically we want to find the distance between any point and this. Which means we want to keep these the same, because these are just the coordinates, and the distance why is this creating a weird pattern? Should be a dot. What am I doing wrong? I really don't understand what am I doing wrong. Basically asking distance between the new points, so this right here is just picking any point, and then this asking us the distance between, for example, right here and this, and then we get this, which is the distance. And then we use that distance, we multiply it. So why is this creating a weird pattern? Well, it's because I'm an idiot. I'm such a massive idiot. It was walking the entire time. The entire time it was walking. It's just the green. That's great. That's fantastic. Lovely. Cool. So actually, if we don't divide, we just plug all of these in. You can see that it is in fact walking. Yeah, great. There we go. So we have two different waves, and then we take the displacement. That's a bit much of a displacement. Oh yeah, we're dividing for the displacement, makes sense. And this is what we end up with. We have two different waves, they overlay on top of each other, and then right here we can see the resulting wave. That's nice. Yeah, it's nice. That is rather nice, because now what we can do is we can basically select any 2 points and check what will be the sum of the wave for these 2 points. So for example, if we select this point right here and this point right here, we can just move them around. Well, it's gonna be close anyway. First wave and then the second wave. And for some reason this is getting larger and larger. Oh no. Oh no, no, no. Why is it getting larger and larger? Oh, no, no, no. Is it because it's negatives? Why would that matter? Shouldn't matter. Why is it getting larger and larger? That's wrong. Damn it, it's always something. It's always something. If I move it to the right... No, it just has a problem. This one doesn't have... Okay, why? What's your issue, my dearest wave? What's the difference between the one at the bottom and the one at the top? Well, the difference is... this one isn't plugged into anything. What's the difference between the one at the top and the one at the bottom? The difference is... this node shouldn't do anything. Should move them to the same spot. There we go. Oh, now it works. Cool. Magic. That's... You probably should say, why is it getting larger and larger so many times? You shouldn't. Anyhow, there we go. That's the sum of the waves. And we can see this is what the waves look like when you separate them. And we can also combine them. And oh, that's much less visible. This is what happens when you separate them, this is what happens when you combine them. Wow, wow, is that the interference pattern? That's, whoa, no way. I can't give a what's your issue, my dearest wave. There, this is how waves walk. Well, right now, the peaks. Oh, I was looking upside down. There we go, that's waves for you. Wasn't that cool? Not the interference part, how do you get it? What? Isn't that crazy? Wow, is that the double slit experiment in real life? I'm losing my mind here. And oh, and one thing which is really cool. Hold on, this is actually really cool. This is actually really cool. Really cool. This actually helps us prove that light. This actually helps us prove that light is a wave. Okay, take a look at this. If I take this material and copy it over again, we have 3 different planes, right? So first let's start with this one, from which we will unplug the Y. This one from which we'll unplug the X. And this one which will have both X and Y. Now, take a look at what happens exactly. When we have... Oh, actually, this is actually more fundamental, kind of... Double experiments, but IRL, no clickbait, gone sexual. Okay, you ready? You ready for the big revelation for why is this so important? This is gonna be actually pretty cool. Take a look at what happens at the very end. When we have the light, right, go only to the right slit. Actually, you know, let me just copy it. It's actually... I want to make sure that makes sense when I explain it, okay? Wow, midnight streaming. Is it midnight? Oh, it is. Okay. Oh, whoops. Well. Was it UV? From 0 to UV? Hold on, what did I use? Come on, how am I already forgetting these? Object. Obviously, it's object. Of course, it's object. Math. Subtract 1 from this. Now, if we have a wave like this, then this is the pattern we're getting, right? Well, okay, technically I suppose it would be a bit to the right. There we go. This is the pattern we're getting because the wave just moves onto it, moves forward, right? Okay, listen, everyone, y'all in chat. I'm about to showcase the underlying principle of quantum mechanics, okay? This is kind of cool. This is kind of cool. They have listened to a lecture from unofficial Harvard professor. My roommate inviting me to a party. Socializing is less important than the double slit experiment, but sadly peer pressure gets me. Don't worry, Nana. Go. That sounds like a perfectly reasonable alternative to quantum mechanics. Okay, so when we shine the light through this slit, we get this pattern on the wall. It makes sense because basically we have waves and yeah, just waves slowly going out. You can see that right here. I don't know how to describe it actually, but this is the pattern we get. If we shine, just you can use it. You can do it with a flashlight if you want. Okay, you can just do it with a flashlight if that's what you're into. Now, when it comes to our second wave, the pattern is different because this one is more on the left, which means we get this on the wall. Once again, makes sense. Right? This one just shine through the slit, cast on the wall. This one shine through the slit, cast on the wall. Perfectly reasonable. But when we shine through both at once, the story is different. Because what you would expect to happen is you would expect to get combined XYZ. You'd expect to get both of these combined. This is what you would expect to get. But if we take a look at our waves, you can see that if we switch off the colors, this is just an interference pattern. Which means that in reality, if they were particles, you would expect something like this on the wall. But if they were waves, you would expect an interference pattern. An interference pattern is what we get. It's not a great explanation. It's a great visualization, but not a great explanation. I certainly could make it work, pun intended. Well, hold on. Waves, not wavelength. Why is there a wavelength? Oh, you can input a number and get a wave. That's cool. Is there something like a... Cool. Alright, so... Hi there, ASIO2. ASIO. I don't know how to pronounce it. If I'm trying. I've read your name so many times, and I always feel like I'm getting it wrong. So, are we using particles? And okay, so here's basic idea. All right, you have two slits. If you shine through the right slit, this is what you expect to happen, and this is the pattern you'd expect to get in the wall. Makes sense. And this is what we actually get. Shine through the second slit. This is what you expect to happen. And this is the pattern you expect to get in the wall. And yeah, we do get this pattern. Right, so left. Now, if we add both of them together, so if we add both waves, if we add both of these together, we should get this, right? But, oh, I'm trying to put it on this side so that they wouldn't be, it's interfering, damn it. Plus right here. Okay, the pen sucks. The pen sucks, yeah, it's in completely wrong place. My point is, if we add the two patterns, this one and this one, this is what we would expect to get in the wall, right? Makes sense. But when we add together waves, we get something different. We get the interference pattern. And the key, most important thing is that the interference pattern casts something like this on the wall. Which means we end up in a scenario where, if I could just... Actually, since we have all of them done, and just copy them over. We can delete those two. I know how to visualize better than with equations, so these two are equal, these two are equal, this plus this equals this plus this equals this, these two aren't equal. What's happening tomorrow? Apocalypse. The fog is coming tomorrow. The fog is here. Have you heard about the fog? The fog will get us all. Or rather, if we want to extend it actually. We could extend like this. There! A graphic explaining how wave-particle duality works. It's perfect. I know what I'm trying to say. I know the underlying principle. I know how it works. I just don't know how to put it into words, and that's the point that I'm struggling with. Okay, when we shine it only to the right slit, then I forgot. We're not saving these. When we shine it only to the right slit, right? Then this is the pattern we get in the wall because the waves are slowly going in. Oh, by the way, this is wrong too. The waves are just moving forward. And we get a circle on the wall. What causes this? Well, that's precisely the thing. This is where the trickiness of it comes, because it doesn't really have an underlying cause. It's just a thing that happens. It's just the way universe works. It's kind of like asking what causes time. Well, nothing causes time. Time just is. Time exists. There is time, right? Like, if I ask you a question of what causes time, then, or rather, what causes seconds to pass, then you wouldn't really have an answer to that. I mean, the seconds just pass. It's a thing. It just exists. And the same idea, this is the same idea, right? Particles behave like waves. Particles have wave-particle dualities. They behave like particles and waves. What causes them to behave like waves? Nothing. They are just behaving like waves. Universe constant like light speed. It's a property, I would say, more than a constant. Okay, so here, let's take a look at this again, alright? If we have a wave, we shine through the right slit, then all of these waves are moving forward, and this is the pattern we get on the wall, right? It makes sense because, basically, it makes sense because from the center, this distance, alright, R1, is smaller than R2, right? R1 is smaller than R2, which means that the further we go from the center in any direction, the longer the distance becomes. So if we have y, right, as the distance from the center, then the greater the y, this is supposed to be an arrow, the greater the distance, okay? Which means that the brightest spot should be the closest to the middle. And the closest to the middle will be right here, and the further you go from this point, the less bright it becomes. Walmart Einstein without the hair, but I can't find the reason to solve it. That's not an insult, honestly. Walmart Einstein's already way up from where I am. Okay, so is everything I've said so far at least kind of reasonable, right? Hi there, Yas. Oh, hi there, Yas, by the way. So, we have a wave, and maybe it would be easy to showcase on the wave. If we have a plane like this, then this distance, right, R1 will always be smaller than R2. Sounds reasonable. Yeah, it does, right? Yeah, precisely. So, the closer the distance, the brighter the area. There we go. Which means that from a wave like this, we should get this on the wall. What's the definition of the Actually, so I think something that oscillates, actually. I I don't know, there's many waves than has a definition actually. I don't know. Definitions are for nerds. Calix, why did you delete the message? I was about to answer. I deleted halfway through me reading this. Self-confidence, kings. Self-confidence and queens. Alright. Now, on the right, we have this point we have this point on the left. No, that's not confusing. Now, when it comes to the green one, the point where the wave starts is more on the left, which means the pattern on the wall will be more on the left, right? I'm waiting for a better moment to ask. Ask away any time. I'll just answer when the moment is right. I ask anytime. So far, the chat isn't quick enough for me to, you know, to actually have to skip over. So far, I'm reading everything because, yeah. Because, yeah, so, okay. So this one casts a thing on the wall which is more to the left. Now, what happens when we shine both of them at the same time? What's gonna happen? And, simple answer to that question, right here we can see when we have the left one and the right one, we can just add them together. And this is the pattern we get. Yeah, this is the pattern we get. We don't even have to guess what's gonna happen when we add them together. Blender is literally just adding them together. Just combining X, Y, Z. Okay? We're just, yeah, if we want, we can just add the brightness, I suppose. We could just do this too. But it's not gonna... Well, okay, if you add the brightness, then... On the edge... Wait, why is it actually glowing on the edge, then? That's actually rather... Oh, yeah, because this is the subtracted one. Does it work on a larger scale? Yeah, it does. It does work on a larger scale. When he's single with no IRL life, damn, Tanzima. Okay, I may be single with no IRL life, but at least I know how quantum mechanics works. Alright, cool. So, the point is, when we add both of these patterns on the wall together, we get this. But the issue is, when we add the waves together, what we get instead is this. Right? Which is, here you can see it more clearly, it's very clearly an interference pattern. Right? We get these lines. So now the question becomes, okay, the question becomes, which one is correct? Should we treat them as particles or as waves? And this is the really nice thing, because right now, all we have to do is just shine the light through two slits, and it's a simple experiment. If we get this on the wall, that means a particle. If we get the interference pattern on the wall, and the blend... It didn't just crash, did it? Did it just... It just crashed. All of my hard work just crashed. This is the background. That's a pic from a couple months back. I was actually back when I was a fireman. That's just, you know, we were doing calendars and stuff. Doesn't matter. Don't want to get into it. By the way, Tensima, you think you're being really sneaky, by the way, just hiding all your alt, as if I don't know who you are. You think you're being really sneaky. I know. It's our video. the famous, you know, from Twitch, satisfactory live streams, the starter of racism. It crashed. It fudging crashed. Fudge, heck, and gosh darn. I have to do everything again. Fine. I'll just set up them's waves. This time I was gonna save, actually. Probably smart. Actually curious why it crashed. Bum, ba-da-ba-ba-ba-ba. Do-do-do-do-do-do. This quantum software, by the way, disappears when you try to see it. Okay. It's in the superposition of existing and crashing. Alright, object, no wait, texture, in coordinates, separate XYZ just for the sake of convenience, combine XYZ. Vector muff, distance, and right here we can pick where we want the distance to be. From this we plug it into muff, multiply it by like 10, and then this is actually the wavelength. I'm pretty certain, yeah, it's the, is it the wavelength or a wave number? I think it's wave number. Of course, not compare. Why can you resize these and rotate? Why is that a thing? Plug in the cosine. Yeah, oh yeah, it's a wave number. That's right. There we go. And now displacement. Divide muff and divide by 10. There we go, we've got them waves again. Wow, that was fun. Oh wait, 20, wrong way. There we go. There's no autosave in Blender? No, there's no autosave. I mean, okay, there is, the file is probably still stored on my computer, but I ain't got the time to look for it. There we go, now we got phase. We could actually make these waves a bit better. Oh, hold on, we could actually make them way better. Oh, that's a good idea. We could improve them a bit. With this equation, representing this divided by S, right? Yeah, okay. I spent the past 6 hours trying to install Arch on an old laptop I never used. Relatable! It took me 7 tries, no, not 7, it took me 4 tries to install Arch. Pain. Did you actually do great question? I think I'm almost done. I had to restart a few times, or I'm installing a desktop environment right now. If you're installing a desktop environment, then that means you succeeded. Because that means, if you can install a desktop environment, that means you have enough of stuff to install everything else. So from that point on, you probably should be able to build up. power, which means we have constant like 2 to the power of, well, that's a good question, to the power of divide by -2. And what are we dividing? We're dividing x squared right, so this divided by -2, and that's also divided by s, and the second exponent right here we want r. And now what this should do is, if I'm right and correct, and I always am, that's not what I was expecting to happen. Huh. X squared divided by s divided by -2. Oh, I divided by -2 twice. Well, that explains it. There we go! Now this... cool. Great. And now we can just divide it a bit more. And now we can just multiply them together with the cosine. This. Oh, this is great. This is gonna be fantastic. Oh, I'm such a smart boy. My brain's feeling fuzzy. In general or from the live stream? Oh, because of the live stream. Look what we ended up with. Okay, obviously I screwed up and forgot to mid-level 0. Look! We got a wave in which we can control the... Let's make this a bit bigger. We have a wave in which we can control the... hold on, values, so... Maybe better with attributes. Okay, let's... oh, we're gonna be so smart now. Hold on, you have no idea just how intelligent I'm being. Not very, but, you know, still I have no idea. How would you know? How would you know? Maybe I'm doing something. I'm not really, but... attributes. So here's what we're gonna do. We're gonna take geometry nodes, and attribute, named attribute, store named attribute this. We're gonna store an attribute which we're gonna call size. Then we're gonna store a different attribute which we're gonna call phase. Then we're gonna store a different attribute which we're gonna call wavelength, and I think that's it, right? And we're gonna store one more attribute which we're gonna call position. Which we're gonna call wave position, which is gonna be a vector. There we go. Now what we can do is go to shading, named or attribute actually, position, and we can take this vector, plug it right here, and it does nothing. Is the capital W important? Yes, it is. Save it in case it crashes. Oh yeah, that's a good idea. This, and then what we need is the rest. So then we have phase, which is a factor which goes into add. Now we can control the phase. Thank goodness I saved. You don't stream that late usually, do you? It depends. Depends. Why is it crashing? Quit crashing! I don't understand why it would crash. Is it because 7 is too high? What about 5? Is 5 still too high? No, it has to be 7. Oh, 7 is above the maximum. Oof. Let's apply it then. There's a bit of geometry, not crazy much. There. Now it's a smooth wave. Why is it crashing? That's what I don't understand. There we go. Now what we can do, by the way, is we can... Actually, no, nothing for now. Phase and wavelength. Wait, they call it the wavelength. That's incorrect. That's supposed to be the wave number. I don't. Did I call the wave number? I have no idea what I'm doing. No wavelength, and it's the third one. Yeah, okay. I just have to crank it up to 11. There we go. Genius of making the webs. Oh no, I'm too smart. Now size, if I may, and size goes in here. Fantastic. Divided by 60. Now we also have control over the size of the wave. This is pretty cool. Like, come on, this is pretty cool. I'm just saying, this is kind of pretty cool. Where did the music go? YouTube stops my music every now and then because I don't know. They like it, I guess. People, what's you good? Now, how would we add two of these waves together? Great question. Well, the best way to do it would be to take our geometry node editor, switch. Actually, wait, can I have a vector? Can I have a boolean? I can have a boolean. Fun. Let's call it wave 1. And let's rename all of these to wave position 1, wavelength 1, phase 1, size 1. Yeah, all of this is gonna break now because we're gonna not have any of them, and then copy. Now we have to plug in geometry. Then size 2. And then all we need to do is just a lot. Hold on. First of all, add together these. Now, oh, it's the make it theme. Wave position 1, phase 1, wavelength 1, and size 1. Why is it invisible? Oh, it went up. Why did it go up? What am I adding it with? 20? No, wrong. 0. Sick! Feeble, you... Are you... Okay? You good? You seem... Okay, anyhow. This is the first one. Now for the second one, we're gonna need to plug them in yet again. So we'll have the next this one, this one, this one, and this one. And this. Okay. And we're going to copy all of this right here. X and Y. Yeah, the difference being this is wave position 2, this is phase 2, this is wavelength 2, and this is size 2. Now for size we want... I don't see a size. What happened to the size? I missed... Wait, I missed one. Damn it, now it's gonna be in the order, it's gonna be all funky. Okay, this is the size. Great. This is a mess. That's a 2. Now. This is the wavelength. Right? Oh no, this is the phase. Oops, this can be 0, this is the wavelength. Sick! This is actually pretty cool. Is Twitch the gaming make it and YouTube smart make it? Kind of. Well, I don't stream on Twitch when I'm doing science because science channel is just way more convenient for people. Most people don't even know that I have Twitch. What you blend it for? For quantum mechanics, actually. That's what I blend it for. And now, this is actually a much better setup. And what we can also do is we can also increase this to go right towards the edge with 1 and 1. Move this left by negative 0.4. Negative 0.4. This one is 0.4. And now we can see what happens when we actually increase the phase of both of them. I'd rather increase phase of both of them at once, because that is a great way to showcase how time evolution affects it. Whoa! It's not really visible, because there's just... because the rendering engine. We've already been streaming for an hour? Wowee. Okay. 140p double slit experiment, precisely. No, it really is what it is. I mean, right now we can increase the size of them. For example, I can bring it up to 10. I can bring this up to 10. Hold on, wrong one. And this one, right? Wait, which one is the face? I'm already lost. This is the face. This will be much better as a render, honestly. The idea is the most important thing. In this case, the most important will be the end video, I think, actually. It's one of these scenarios where end video could be a bit better. Yeah. Light, ain't it crazy? And what's really cool is that we can actually copy this now if we want, and we can just... Oh wait, booleans, yeah, that's one thing I forgot about. So you have wave 1 and wave 2. And then... more multiply both of them. Wait, no z, not z, only y. Whoops. Alpha. Alpha. Sick. Cool. No. Why isn't this working? How do you plug in Boolean? I have to go now. We'll be back in a bit. Alright. Well, I'll be ending the stream too soon because, let's be real, we only care about the 400th. Cameras, well, I just remember they always say, yeah, that's precisely actually why, and that's the magic of waves. No matter the medium, waves are the same up. ASMR make it. Wave 1. Is it not wave 1? Is that the issue? No, it is certainly wave 1. With value being Boolean. That's certainly a pickle. How do you... move the Boolean around? Okay, so alpha apparently is higher than 1. Oh no, no, wait. Factor? Oh. I was just looking at the wrong... I was looking at the wrong object. Well, isn't that just great? Cool, I was... great. Sick. I was just looking at the wrong object. There. Now we can turn off whichever wave we'd like. And turn off the green one, turn off the red one. Festive! Well, fun! That was fun. I think I'm gonna end the live stream now. I have to go walk in the video and prepare for tomorrow's live stream. Wanna make sure, I really would like to make sure that everything is gonna work. And in around 18 to 20 hours. Right? Yeah, 18 to 20 hours I feel like we're gonna start the live stream. Show this to a caveman. I feel like imagine show anything to a caveman at this point, just similar reaction. Anyhow, I suppose for now be it. Thank you everyone so much for watching. And have a great day. Bye.